Hello, everybody. This is Mr. Hennon. I was just going to go through the notes on the transfer of heat through convection. Now, convection is going to be a little bit easier, and so I'll start off with the actual definition of it. Convection for us is actually going to be defined, here, let me get a pen, as the process in which heat is carried from one place to another by the bulk movement of a fluid. So if I think of basically a pot of water and the fact that this pot of water has some fluid in it, it's going to kind of go around in this circular motion. And because of that, you're actually going to get the movement of heat. So the bottom is going to get hot, but then this is going to circulate to the top. And so it's going to make the top get hot, but it's the movement of that fluid that actually does it. And we use this all the time. So for example, your heating vents are typically on the floor of your room so that heat can rise, go to the top, and you can actually get a convection current, and then that pushes the cold air back down. This cold air gets heated back up and it goes back up, and we just kind of keep that fluid flowing. The same thing is going to happen in your refrigerator, except it's kind of the opposite. We put the cooling on the top so that the hot fluid inside, the hot air inside of the refrigerator can hit this cooling, and then it's going to drop back down and create this little convection current going around. So each location is designed. Sometimes in basements we have heating vents on the ceiling, but that's more of just the way it works. It's actually better to have heating vents on the ground. And technically it would be better if we had some cooling vents up top, but that doesn't always happen. This also happens with the concept of thermal. So we talk about warm air at the ground level, and then it rises, and that actually causes these thermals, this hot air flow upward. This is also convection, the movement of a fluid. That could be air or a liquid, either one. The way your engine is cooled is going to actually be convection. So we have radiator fluid that's flowing through the whole system here. And the radiator fluid is going to come through here. It's going to actually weave back and forth around your cylinders. The cylinders are warm, so that fluid is in contact with them in some fashion, and then it comes back in here, and then it goes into your radiator. So even though it uses the word radiator, it's not actually radiation, it's actually convection. What we do is we actually then use the movement of air, so the fan is actually pulling in air this way to cause it to actually cool that off, and then you get cool fluid again. So all that kind of works off of that same principle. Now, with that in mind, if you notice, I haven't thrown out an equation yet, and that's because we're not actually going to have an equation. This slide just kind of goes through convection again, the fact that it's dealing with this macroscopic portions of the fluid, they're flowing through there. We talk about forced convection with a pump. We talk about just natural convection with the movement of air and density changes and stuff like that, and we get that kind of idea. But heat transfer by convection is more difficult to analyze than all the other heat transfers, whether it's conduction or radiation, because we don't have a simple kind of concept. There's different kinds, there's different parts to it. And I like this part right here, where we talk about there are some different things that affect convection. You need to know the fluid velocity. So the faster the fluid, that's going to change how much convection there is. The viscosity of the fluid is going to affect it. Which is basically the fluid friction that you have. The heat flux, so that's the amount of heat flowing through a particular area of the surface roughness, the type of flow, all these things affect it. So the nice thing with convection is you just need to remember that it's a flow of a fluid that is transferring heat, and you're good. We don't need to go through a particular equation. We're not actually going to solve anything, but we will actually still keep that in mind. So just kind of keep convection in your head, and we'll go from there. Hope you enjoyed this short little edition of the Henstitute.